Hello.
Hello.
Yeah, am I audible?
Yes, sir.
So, good morning to all.
Good morning, sir.
Yeah, good morning.
Good morning, sir.
So,
Good morning, sir.
yeah, good morning. Good morning. So, today we will continue our last workshop actually session regarding concept GA drawings for that school building. Uh, Let me share my screen. So, this was the problem actually we were discussing last time. We will continue today with this again. Okay, let's discuss here. I think all of you are now comfortable with this. So for this is also classroom 2 and 3 is also same. So we can have a same kind of, we can say, beam and column positioning. Right. So for this, it will be like this. Then again, now you can see here, the column is having offset inside the staircase. So is it okay?
No, sir.
It is not okay because it will have a problem to the circulation. Okay. So I need to shift this like this. Now, when I shift this like this, you will see that your beam will not rest it clearly here because this column is also to the right side. And generally it is not accepted inside the staircase. So I will shift this also. Okay. And then I can rest this beam over here. Now it is okay. And then same beam I will rest over here. Now, as we have already discussed, if you want this column position, then you need to shift the door. So you can ask the architect, please shift the door little bit so that your column will not have any issue. So otherwise you can see here, ideally in planning, architectural planning, see the door starts from here, but your column size may be bigger size and it may go inside the opening. So they will shift the door, which is not a big deal for architects in such situations. See, there is always a resistance by the architect to change something in their drawing, but you should insist in such situations. You should justify through technical, we can say, evidence or technical requirement. So this is the case, and again, this right portion is also same mirror. It is mirror like this. So I will just keep this for the time being. Now let's discuss about the classroom part first in the beginning. Now you can see here the span of the classroom. So last time we discussed that this ratio is 7.7 by 6.1, which is less than 2. So it is 2-way slab. But generally in residential or commercial buildings, I recommend as far as possible, uh, don't design slabs more than 6 meters or 7 meters. Single slab, I'm saying. Are you getting what I'm saying? So the span is very big. In general, the span of 3 meter, 4 meter are comfortable as far as serviceability is concerned. And as far as overall, we can say cost effectiveness is concerned. So in this case, first, as a structural engineer, you should try to keep the span of slab as minimum as possible. Minimum means optimum, I mean to say, not. So let's say if the classroom size is 9 meter by 9 meter. So can you design 9 meter by 9 meter slab, RCC slab? Hello? Let's say it is 9 meter by 9 meter. Hello? कर सकते हैं डिजाइन 9 मीटर में? Any views? Hello? Any answer? See, generally we can design any kind of slab. There is no problem actually. As a structural designer, we can design anything. But as we can design anything doesn't mean that you should design as you think. So you should think the other parameters also while designing. So generally what happens whenever there is a big span, either it is a big span of slab or it is a big span of beams, when span increases, the deflection also increases. And as the deflection increases, bending moment increases, you need more thickness of the slab, or you may require more depth of the beams if you are designing beam. So what happens? Generally, don't try to design bigger spans as far as possible, as far as slab is concerned, because otherwise it will have a serviceability issue. See, when you use such a big slab, you need to give more thickness, and there is a possibility of feeling of vibration actually. See, it is not wrong designing heavy spans. The people design even 9 meter, 10 meter also. Generally, they go to post tensioning beams. But designing RCC beam more than 8 meters is a really very thick beam, thick slab it will come, and their serviceability means deflection will be more, and you will feel vibration whenever you use this room, let's say. So, and you know that whenever you feel vibration on slab, then you feel scared that there is something wrong in that design or something. So it is not really comfortable to work on the slab which is vibrating. Okay, so, and I generally recommend to start with, see, as conceptual drawing is very, we can say, creative phase, and as it is a creative, there are many options actually. So it becomes difficult for us where to start and what to do. But general guideline I would like to give you, generally prefer 3 to 4 meter slabs. Generally, I'm saying it is not hard and fast rule actually. Try to keep 3 to 4 meter slab spans, slab span, so that the thickness of slab will be comfortable and will not have any serviceability issue. Like residential building, all of you know the sizes are like this. I don't say that I don't design for 5 meters. Even at some cases, you can think of 5 meter also. There is no problem. Okay. And whenever these kind of slabs spans are there, 3 meter, 4 meter, and 5 meters, you can assume slab thickness as, let's say, 125 mm here, something. It may be here 130 mm, and here it may be, let's say, 140 mm, something. Okay. Assume thickness. Generally, these are the thicknesses we get in the slab design. So this is only a thumb rule to start with. And if you are not confident about thumb rule, then all of you know that we have Excel programs with us, and you can put the values in the Excel program and get the thickness, and then you assume that thickness in the analysis. So we are using these Excel programs even before the analysis. So see, all of you know that we model the structure in ETABS. Then we do the analysis, then we design the slab, design the beams and so on. Not necessary that you should use these Excel programs after the analysis only, because these Excel programs will help you to give the overall approximate sizing of the members. Now let's see. So as I said to you, try to have minimum spans for the slabs. What is happening due to this? We will have a controlled deflections if the spans are less, and we have less vibration to the slab. The more span, more vibrations. I know that for more span, I will design more thickness, but still. Now, as this span, I see that it is more than 4-5 meters, 6 meter by 7.7 meter. Then I should really think whether should I really provide such a big slab or not. So what is the second solution? So I don't want these bigger spans for the slab. How can I reduce the slab span?
By providing intermediate beam.
So we will provide intermediate beams. So generally providing this, cutting this length will be a good choice. Okay, so this is a choice. And then what is the span now remaining? This was 7.7. So divided by 2 roughly. So it will be 7.7 means 3 point. No, not 3 point. 85 something. Okay. Center to center, I'm just. Now this is 3.85 by 6.1. So any shorter span is fine. So now it is comfortable, I think, from our we can say serviceability point of view. It is a good choice as a designer. I don't say that this is wrong. This way also we can do. We will solve the both way. Now 3 point. So what is the Ly by Lx? It is 6.1 divided by 3.85. How much it comes? Will it be less than 2?
Yes, sir.
Yeah, it is less than 2. Still it is less than 2. So it will be two-way again, right? So let's say for the study purpose, we will consider both the cases. So as a choice, see, sometimes architects are not happy with such kind of beams, intermediate beams. So they say that, can you provide without beam? So there will not be any problem. So see, there is always we can say a debate between the architects and structural engineer. But whenever there is a we can say structure like school buildings, college buildings, or public buildings where the aesthetic we can avoid generally, means we should more give focus to the safety and serviceability part of the structure than the aesthetic. I know that if you look to the ceiling while in the classroom, then this beam will have offset. And if this offset is in the living room, let's say, so you are staying in residence, and in the living room you have this beam, so definitely you will not like this. So architect will not like this. As a client, you will also not like this. So in that case, you can provide such a bigger spans. There is no problem, and you need to design thick slabs. But as I said to you, there may be possibility of serviceability issue, or you need to give more thickness to such kind of slabs. But I generally recommend for residential and public buildings, school buildings like that, better to keep the beam. See, in classroom, the students are not looking to the ceiling always. Yes, the classroom is for training. And even though there is a beam in the ceiling, you see what's wrong. Nothing wrong, isn't it? Because that aesthetic part in the classroom is really not a big issue. Should not be. So we can convince the architect, I want this beam because of the slab thickness will be more and will be vibration issue on this. So we can answer such kind of we can answer to the questions given by the architects. So let's say this is our one of the choice, and for study purpose I will keep this also. But as a structural engineer, I will be happy with such kind of solutions. But yes, every decision you take, either this or this, there is an implication after that decision. If you take the decision like this, then there will be implication. If you take this decision, there will be implications. So you should know what are the implications after taking any decisions. So these are the concept drawings which we are preparing. That means we are taking decision at every point. So keep in mind, so it's not a simple and straightforward problem. We are taking one decision, then thinking over the decision. For example, this column was here. So is it okay? So you feel that there will be problem to the circulation to the staircase. Then I am shifting. So I have taken one decision first. Then I have changed my decision and I have shifted the column to the left side. Again, then this beam was not resting on this column properly. So I also shifted this column. So every time I take decision, then analyze the decision. And if the decision looks correct from all point of view, then I freeze the decision. Then I again go to the next point, again go to the next point. Then here, now here I was thinking why to provide such a bigger span slab. It will have serviceability issues. So why not to provide one beam? So I have provided one beam. Now once I provide one beam, it will be two-way slab. And then I need to design and analyze all these things. Now for the study purpose, we will keep this slab also. Now let's see what will happen to these two options. So if you want to say, okay, I'll want to do one thing. ये रहने दो ऐसे, थोड़ा आगे जाएंगे, बाद में फिर slab thickness and वो decide करेंगे. Now our problem is not yet completed. We need to provide this slab and columns over here also. Now so let's discuss about the passage part now, so that this passage and classroom will be finished, because these classrooms are same. So the framing which you have suggested here is applicable to the left side also. So there is no problem. Okay. Now let's quickly now put the columns in the passage area. अभी पैसेज एरिया में कहाँ कॉलम डालने चाहिए ऐसे आपको लग रहा है?
Sir, near the stairs.
Here.
Two columns near the stairs.
Edge of
Yes,
the
sir.
stairs.
One here, one there, and स्टेज के कॉर्नर्स में भी होना चाहिए सर. 4 कॉलम आने चाहिए. 1 2 3 4.
Yes, yes. Now, see, generally, even though we take any decision of the columns, generally, the architects, we take the permission of the architect. Is there any problem, aesthetic problem to the columns or functional issue to the columns? Okay. So let's say we need to think architecturally and we need to think structurally also. Whenever the architect doesn't give any suggestion, then think from both the directions. And that's why, as I told you, we should have the knowledge of architect also. Basic part I'm saying. So there is one choice that let's say here, if I put column like this, let's say for example, then you know that there is a ramp here and there will be problem to the ramp. Yes or no? So this is not
Yes,
a
sir.
good location because a ramp will have a problem. Now there is one more solution that can I provide here like this. Okay. So this way. Now
Yes,
let's
sir.
try something. Yes. Then again, let's try. Then as this, you see, this is a symmetric. Always have maintain the symmetry if the architectural plan is symmetric. So these are the two things. Okay. Now there is one more way of looking at this. See, all of you know that whenever you enter in the school, generally there has to be equal openings. So there is a possibility. I'm just that there should be 3 divisions from here. So that is also one of the possibility. So what I'm saying, just, and then you can have column if you wish at the corners also. I'm just telling you why I'm taking this. But this is also one of the choice. Just discuss with architect. See here what I'm doing. Let's take inside, let's say. So if you see here, if you have visited such a schools, you might have visited schools which are having such kind of a general arrangement of the school is like this only. Now you can see there is one choice that, see, I am keeping this distance as same, x, x, and x. And if you look from this, whenever you enter into the schools, you will see the columns, and you will see the openings which are uniform, and it may give good feeling or aesthetic part, I can say. Anyway, we are not much bothered about this planning. Please discuss with the architects generally. But let's say now I am in a position of the architect, and I will be happy if I have such columns in this plan, so that these openings will be good, and I can have some, we can say, uh, some aesthetic part to these pillars. Okay. So all of you know that many times there are pillars like this. So, and say, let's say this is a pillar, front elevation I'm talking. And then many times architect is giving such kind of shapes to the column, aesthetic, we can say, finishing like this. Okay, can you see this? And when you enter into the school, this you'll see this such kind of framing, not elevation rather. So these openings spans are same.
Sir,
And
can I
as I
ask
said, there is a,
one question?
yes, please. Yes, yes.
Uh,
Go.
Sir, can this be a possibility that if we look, if we consider the aesthetic point of view, and if the columns are giving more offsets, than in place of rectangular column, we can provide circular columns also,
Yes,
so
yes, yes,
that
yes. Circular also. So here,
they can
circular
they
also.
can provide. Yes.
Yeah. You can provide circular also. So if the architect is having any intention of using that circular shape in the aesthetic part,
Yes.
as I
Yes, sir.
shown you the pillars and that,
Shown you the
definitely
elevation. Yes,
circular
sir.
is also, that can be done.
Okay.
Circular भी कर
Okay.
सकते हैं.
Okay.
Generally, we take these decisions along with the architects, and we
Okay.
should give the solution to them. So circular also
Okay.
will be a good choice. There is no problem. Yes, but
Okay,
we
sir.
should understand their concepts. Now, let's say we will go with this for the time being. As a structural engineer, I will be happy to have the column exactly in front of this. So please, so that I can provide the beam here in this line, right? And I will be also happy to provide column over here. So so there are two thoughts. One is the structural engineer's thought, and second is the architect thought. It is always there is problem always, or many times rather, that structural engineers locations of columns are not agreed by the architects, and structural engineer also not agreeing the architects locations. So there is a possibility. But now see, whenever you provide the column in front of this, so that, why I'm doing this, just to keep the beam here. If I want to provide a beam over here, then it will be easy for me to rest on the columns. But as I said you, then this x distance which I discussed, it will not be same here and here, and the symmetric part, the view may get disturbed. And if the view is getting disturbed, and if it is a really dominant, we can say, part of the planning, if this is really important from architectural point of view, where he cannot compromise, then you cannot provide such a column position, then you need to shift it. So better shift it as per architecture requirement rather. I know that then beam will rest on the beam instead of column. I can let's say here, and again let's say it is here. Now I know that the beam will not rest here, and then once you provide the columns over here, then you can provide the beams. So this planning is always, I can say, it's a creative phase and brainstorming phase of the, and then you will see, and this is really interesting phase actually, always this concept planning, because whatever we have got the knowledge, whatever experience we have, whatever creativity we have within our mind, everything is used over here. That's why this phase is very much important, planning phase. Now let's put these columns, sorry, beams here. Now offset, you can take decision, either put the offset inside the passage. Generally inside the passage, offsets should not be there actually. We should avoid that. But architect is happy with inside offset or outside offset, you need to ask. If he is using the offset of columns as aesthetic part, then you can take outside that. Okay. So many times you know that columns are also exposed. And its offset is used for the aesthetic purpose. I think all of you are already existing students from our batches, and I'm expecting that other technical knowledge, conceptual knowledge is clear to all of you. Okay. Now let's say this is your framing plan. Okay. Then there is an issue at this corner. Can you see this? क्या करेंगे? See, this kind of slab arrangement is not good. So this generally I recommend, if you have all round beams, then it is a really good slab arrangement. Don't have such kind of ये. So कैसे करेंगे इसको? फिर arrange करना होगा तो. I can extend this. And then I can have one more beam here. Like this maybe. Then at least I have some beam around this. And if you feel that you are not even comfortable with this, then you can extend this also. So that there will be a small slab over here, then other bigger slabs over here. This is also one choice of putting the. Now, I ask you whether we should provide this beam or not.
Yes, sir, we should provide it.
Why?
Sir, depending upon the span, the
Mhm.
span is 2.8 meter. So, in order to keep the columns and in order to keep the frame intact,
See, there
there
is a
should.
one choice that, so let's say we will think over both the choices. There is no problem. So definitely, as I said, as it is a creative, either you can have beams or not. So if you don't provide any beam in the passage like this, so this will be one-way slab. All of you understand this? There is no problem, right? It will be one-way slab,
Yes.
pure one-way slab, big strip, almost 24-meter longer, and then shorter span is 2.8 meters. So this is also one of the choice. You can take such a decision also. There is no problem. Many times architects are not happy having beams within the passage. But if you have any strong reason for putting the beams, then definitely you can take the decisions, and it is really helpful if it is structurally feasible. And there is second choice. So इससे क्या होगा? So I will do one thing. अभी ये मेरा S1 है. Let's see S1. And second choice, let's take second choice. Let's put 1 VM over here. So this is one choice. So definitely there will be some advantages, disadvantages of everything in general. And as a structural engineer, we should get the advantages of the structural safety, structural serviceability, durability, cost. Okay. So as a structural engineer, we should emphasize more on the safety first, then strength part, then serviceability issues, durability issues, and cost issues. Okay. So our main aim should be in this direction. See, it is not necessary that you should agree with the architect always. See, architect will always think that the structure should look beautiful. So he will always bothered about the aesthetic part first. And he is always bothered about the functional part, means use of space. Aesthetic and functional part is very much important from architectural point of view. Okay, so he will definitely stick to his aspects because it is the, we can say, soul of this, his part, we can say, work. And definitely he will stick to his point. But as a structural engineer, also we have our parameters. I'm not saying that I am not agreeing with the architect, but I will also see that my parameters are important, and that is nothing but because I'm taking the responsibility of the structure. So safety is first at any moment. So I will always think from the safety point of view, always first. Safety covers, we know the strength, that is, it should not break, it should cover our IS codes and that permissible stresses and so on. It should have a serviceability criteria, means deflection should be within the limit, crack width also should be within the limit. Then durability means long-term life, we can say, and then cost. Okay. And aesthetic is definitely, then I will definitely think over the architectural part, that is aesthetic. Aesthetic and functional, definitely, yes. Functional I will first see first, and then I will think over the aesthetic. So definitely I will give more emphasis on these parameters as a structural engineer, and it should be like this. Otherwise, what is then your main part will go out. So you will, if you agree with the architect 100%, then you will compromise these things sometime somewhere, and there is a problem. There may be problem. But I know that there will be always debate between you, and be ready for that. And please justify your solutions with giving technical evidences and reasons, and then they will also agree. There is no problem. I know that you need to agree 100% from the architect, and architect will also not agree 100% from your side. So negotiate between yourself, and then you will get the good final solution, we can say, which will have a aesthetic, functional, safety, serviceability, and all. So these are the general guidelines, because I know that many people ask me how to handle such a situations. You can handle, there is no problem. Okay. Let's see here. Now we will see. 1 minute. Yeah. Now we were discussing on these beams whether should provide this. See, as far as architectural point of view is concerned, aesthetic and passage, there should not be beam. as I discussed previously. It is better to have a clean passage without any beams on the ceiling. But I may get a structural advantages of this. Can anybody tell me what will be the advantage of this beam? If I take such a decision, agreeing with the architect is a really good decision. हमें कुछ ज्यादा करना नहीं है. फिर भी as a structural engineer थोड़ा सोचो. Let's say we have such an arrangement. ऐसे कुछ तो है. So what will be the advantage for me if I provide these beams? Apart from aesthetic, forget about the aesthetic for the time being. क्योंकि उससे उतना भी बड़ा aesthetic issue नहीं है. दिखा तो दिखा थोड़ा पैसेज में, क्या प्रॉब्लम है? And if we
So there
is,
will be proper distribution of load if we provide such a beam.
Yeah. So I will. Let's say these are S1, S1. So previous case was no. Okay. Let me remove this just to compare. So let's say I have beam this B1 and let's say this is a B2. Okay. So there are two beams and let's say this is my B3. But B1 and B2, well, I want to compare these two beams. So if you calculate, let me go into the next screen. So there is a beam B1. Let me draw the frame diagram. Thoda single diagram hi leta hu main, single floor. I know that there are multiple floors. Okay, like this. So this is my B1 and I have two columns on the. ये B1 है ना हमारा. Yeah. So this B1 and I have two columns. One is having orientation like this and one is having orientation. So weaker and we can say. So let me draw. ये weaker है. Weaker means smaller dimensions. So this is like this and this side is having deep column. Okay. ऐसे ही है ना ये. One column is like this, one column is deep like this. And so this is your B1 and then it will have a load which will come from slab, walls and whatever. All the loads will come to this and it will have a bending moment. Yes. So the bending moment will be something like this. As it is a weaker column, the bending moment on the weaker side is less. All of you know this. And as it is a deep column over here in this direction, it will attract more moment. So it may be something like this. Okay. Smaller moment here. And this moment will transfer into the column. Bending moment. And this also will transfer to the column. There is no problem. So this is one case. Let's say we have this bending moment as let's say imagine 50, then it is let's say 60, let's say it is 70 something. Okay, and it is transferring here maybe 50. So this is one case. Case one where I don't have any overhang beam. Now let's take this case B2. फिर से निकलता हूँ बेटर. So let's say, so यहाँ overhang है ना मेरा. So there is a beam like this, then there is a column, then a weaker beam, then this. Okay. So now this is your case. As our beam is resting on the beam, so something like this. And we have a load here and here also. What will happen to this? If this is the case, what will happen? ये भी support है. So you can say that your bending moment as the cantilever, no, it's not a cantilever, but it's overhang we can see because it is supported here. Column पे rest है ना, ये column या beam पे rest है समझा. Okay. There is a support, it is not cantilever, please keep in mind. So I am just drawing this. This is your beam. The beam is resting on this. And this will have a bending moment, something like this, because it will have, it will also act as a cantilever generally. So ऐसे कुछ तो होगा उसका bending moment, let's say. And then again here somewhere like this and this, let's say. ऐसे कुछ तो होने वाला है. And the column will have very less moment here. Because now you can see this 60, let's say got 40, then 50 got, let's say 60 or maybe something. So this moment got reduced, this 70 got, let's say 50 something. Okay, there is a possibility, or it may be something 50, depends. See, because of this beam, this moment got reduced actually, and it got distributed in this beam. So there is a uniform distribution of bending moments. So this is very important, uniform distribution of bending moments, because now this person is sharing with this. Previously, B1 was only the person who was sharing the bending moments. And due to that, even this column was getting more moment, let's say 50 here. And now it is, let's say 5 kilonewton only, because now the column is having less moment because the bending moment got shared in this beam B3. This is my B3 and this is my B2. Okay. So it got shared here. So I got a uniform distribution of forces. So and as the moment will reduce overall in all directions, then your steel will reduce, and there will be, we can say, indeterminacy to the structure. So the more beams are there in the structure, the more columns are there, it will be indeterminate, more indeterminate, we can say. And or all of you know that redundant is the word, redundant or redundancy. The more members are there within the structures, either beams, columns, it will have more redundancy. That means it will perform well in earthquake. See, earthquake में जितना ज़्यादा members रहेंगे उतना they will share each other. So if there are many members and if somebody fails, there will be neighbors who will share the forces. So this is the case generally. So I would say this is a good choice from structural point of view, because the moments are getting reduced and they are transferred uniformly in different members. So that is the, we can say, choice. I'm not saying it is the only choice. And then this beam will help. It will reduce the column in this moment in this column, and it will also reduce the bending moment of the beams B2 and this column also. Now, whatever I'm saying, please check in the software in ETABS. You will understand, because this you cannot understand by manually, but you should get a feeling by manual calculation. I suggest please do the model, at least one frame model, and then check the bending moments, and do this also B1 and check the bending moments. Now, let's go with the structural engineer's viewpoint of view. I know that architect will not be happy with this. Now discuss with him and take a decision. अभी structural engineer के बारे में ही बोलेंगे चलो. Now this is my beam positioning. Okay. Now let's again go to our slabs. If I provide this slab S1, let's say, and let's say you are taking this decision also, bigger spans. Now what will be the size, thickness of this slab? S1 का कितना रहेगा? 3.85. So if you don't know how to get this, if you want to design slab, what data you require, or how will you design? Let's say, कैसे करेंगे design two-way slab?
Thickness of slab, dimension.
Yeah, dimension, and there are, you will assume lie loads, loads चाहिए उसके लिए, span, boundary conditions, and then you will do that analysis, modification factors. There is a process of two-way slab design, and those are always already, let's say, conversant with the design of slabs. They can use directly Excel programs, and we have the Excel programs, all of you know, for slabs and everything. So you can directly use Excel. Those who knows the two-way slab design, and those who don't, please do it manually first, and then you can use this comfortably. Now let's say my S1 slab is, so boundary conditions are there. This is a continuous, this is continuous, this is simply supported, this is simply supported, like this. Just as you are planning, don't go much in detail of the design. Just You can assume 4H discontinuous also, there is no problem. Just for, because I'm doing this only to check the thickness required. And what is the span? Shorter span is 3.85. Longer span is 6.1. 6.1. Let's assume 125 in the beginning. Live load कितना रहता है school classroom के लिए? Where will you get this information? What is the live load for classroom?
Highest code.
So 875 part 1.
IS85 part 2.
875 part 1.
Part 1
Part
dead
2.
load करेगा ना?
Part 2, sir.
Sorry, part 2.
Live load part 2.
Live load part 2 ना? So यहाँ फिर you can go here because I'm interested in getting the live loads. अभी कौन कौन से rooms है यहाँ? Now you should, अभी ये क्या है? Residential building, okay. Hotels. Please read the codes. Educational buildings, yes. Classrooms. So classrooms, lecture rooms, they are having live load as 3 kilonewton per square meter. Okay. So there are other rooms also you can see here, and you can use these loads for different loads. Library is having more load, 6 kilonewton per square meter. Now our case is let's say classroom case. So I will put the live load as 3. This is my span, and then finished load generally we take 1.5 tiling and all screed and everything. I think those who are already done with the high-rise building, you know that design basis report and how to get these numbers. So those who are very new in our batches, please don't mind. You'll learn this in the upcoming sessions. Just for the time being, please assume this. It is a 1.5. It is a plain tile work and screed work. And we are putting steel at the shorter span. And then let's assume 8 mm bars. And how much is required AST here? 477. Let's put 500. Here you will see that 125 mm is not sufficient because it is asking, rather saying revised thickness or AST. That means 125 is not sufficient. So let's provide 130. Go down at the bottom. Again, it is saying revise AST. So still 130 is not fine. Then again go to 135. Again check. Still it is not satisfied. 140. Now here you can take a benefit of this whenever you are getting problem. So I have assumed this as a 9 case, which is simply supported. And as I know that it is not really simply supported because this is only 2 edge discontinuous and these edges are continuous here. So you can get in such a case if the thickness are going very high, then take the real conditions. अभी कौन सा है हमारा condition इसमें? 3 number, right? 3 number है ना? Then check it out. तो safe आ रहेगा. Okay. So I would say okay आ रहा है ना final status. So 140 is the thickness. So if you assume this case, then your thickness will be 140 mm, which is not a big number. It's okay, comfortable. Now let's start with S2. There are 2 choices. One is S2 case and one is S1 case. So I have provided beam over here and I have split the slab in 2 parts, 3.85 by 6.1. Now let's design this. What is the size of this? 6.1 by 7.69. Why करता हूँ मैं, चलो. 3 कैसे होगा ना फिर. 3 नहीं होगा ये. 3 is fine. Okay. Now, kitna ye 6.1. LX is shorter span, LY is bigger span, that is 7.7. Na? Thickness, let's assume start with 140 and live load is 3 and SIDL is also 1.5. Let's take thickness as 8 mm, whatever. यहाँ समझो कितना 500 लग रहा है, right? कुछ तो इशू है क्या? Let's do here only 6.1, 7.7. So the spacing is coming out to be 8 at 75, which is not comfortable actually. Generally, don't go more than 100. So let's take the diameter as 10 and just go over here. Now it is saying revise is thickness. L by D ratio is 40, so it's very high. So please increase the thickness. I need very high thickness, I think. जाओ कितना आ रहा है यहाँ? 125, 175. Okay. So 175, and many times you require, so in such slabs 200, 175 like that. So requirement is 175. So whenever you go more than 150 mm thickness, so generally there is a possibility of serviceability issue, and possibly you should try to avoid such things. But you can still do this design also. Now these are the two cases I can say. Architect will be happy with this solution. Abhi, now what's next? Now here also, now let's discuss about this column. So this is a horizontal orientation of the column. This is vertical. Now tell me whether horizontal orientation is a good choice like this or vertical. यहाँ मैंने vertical किया तो अच्छा रहेगा या horizontal अच्छा रहेगा? Currently I am only discussing the gravity part.
Sir, horizontal is better because offset फिर दिखेगा वो classrooms में या passage में.
हाँ, ये ऑफसेट तो वैसे भी आने वाला है यहाँ भी See, ऐसे भी ऑफसेट आने वाले हैं ना. हॉरिजॉन्टल रखो या वर्टिकल रखो, देयर विल बी ऑफसेट. So okay, there is one point that architectural aspects. So there may be some architectural, we can say, suggestions given to either horizontal or vertical. He may not be happy with this vertical as far because he say that offsets are there, maybe. और structurally कौन सा अच्छा लग रहा है आपको?
Horizontal one.
Horizontal वाला sir.
So bearing support will be extra for beams.
Generally horizontal, see, my opinion, my suggestion, you can verify the whatever we are discussing, you can verify in the model. But I feel this is a better choice because see, whenever you any beam is resting on the column, generally the spans are large spans, isn't it? And it is single, we can say, and due to that what will happen, there will be moment along the deeper axis of the column. Okay. But here the bending whatever are generated, they will be on the weaker axis of the column.
एक second में.
Huh? So this is your bending moment which is on the weaker axis developed due to B1. And This is also bending moment here, but you will see that this bending moment is on the major axis and this is on the minor axis. And definitely whenever moments are more on the minor axis, the steel requirement of the column is more. Okay. So that's why this looks okay from my point of view, because the moment will be, even though there is a moment, let's say this moment is something 50 here. यहाँ थोड़े कम होंगे लेकिन फिर भी ज्यादा रहेगा 40 let's say. So if you design this column in the on the deeper axis, steel requirement will be less because we have a more depth in this direction along the direction of the moment. But here we are having very less depth, the thick, that is 230 width. So I think this may be the better choice. But as I said to you, there is no any final stamping on any decision what we take. Whenever we take any decision, there is an implication. And that implication you should accept. So there will be definitely implication from all the parameters, either cost, aesthetics, serviceability, or whatever. So as I already told you, if you take this decision, there is a possibility of serviceability issues. I generally recommend more than 175 in this case. I will not go with 175 in classroom. I will suggest to have a 200 mm thickness as a structural designer. I will reduce the steel, there is no problem. I know that 175 is requiring more steel and 200 will require less steel. So I will be happy to provide lesser steel and more thickness. Why more thickness? For serviceability issue. And I will be more happy to have this solution because I'm not bothered about the serviceability issue. I know that serviceability issue is very dangerous issue. And that's why I generally take the serviceability decisions first and then take the decision of strength and all. बाकी तो करना ही है लेकिन सर्विसेबिलिटी को कॉम्प्रोमाइज मत करो, बहुत बार प्रॉब्लम्स आ जाते हैं.
Sir, one question was there.
हाँ.
If the architect doesn't agree with the 200 mm depth of this depth of slab, so then what are
No,
the
architect should agree because thickness of slab is not an issue to the architect most of the time. Yes, he will have the issue with the depth of the beam, definitely. Because if you provide more depth, then there is a possibility of, say, coming near the floor to floor height will reduce. Not floor to floor, floor to soffit of the beam will reduce.
Yes.
So he will have more issues with the beam depth, but not slab depth. Don't worry, 200 is very comparatively very less depth.
Okay. But are there some other methods, sir, to reduce the depth of the slab?
See, depth of the slab reducing is not really possible because most of the time, yeah, people do post-tensioning methods.
Post-tensioning, yes, sir.
They do the post-tensioning, but still there is a limitation. You cannot reduce so much depth because there is a shear force comes, and then you need to provide here drop panels and so on. So there is always, I said, whenever you take any decision, there is an implication. So we feel we cannot reduce beyond certain limit. So 200 का मैं बोल सकता हूँ 175 में हो जाएगा, let's say. But if you say मैं 140, 130 में बैठा सकता हूँ, no, not at all possible because there are shear issues also at the column location.
Okay, sir.
So I generally recommend please go with the RCC sizes, and even though there is a PT, then you can say 25% reduction will be possible. Let's say, for example, हो सकता है वैसे. So this is your planning.
So, but post-tensioning can increase the cost of the project also.
Yeah, can increase because the post-tensioning is having different agency. Then you are putting RCC structure also, post-tensioning also. Yes, but only that gives the advantage of reduced sizes. So maybe functional or architectural aspects are there many times. Many times floor to floor height is not much as per the planning requirement. And if your spans are bigger, then the thickness of beam will be very high, say. So in that case, PT is suggestive. It gives functional benefit, but will increase the cost.
Okay.
हेलो
now, yes.
सर, जैसे यहाँ S1 जो था स्लैब 1,
Mhm.
वहाँ पे जो आपने ये कॉलम दिया हुआ है और उसके एकदम बगल में वहाँ पे बीम को प्लेस किया हुआ है, मतलब नॉट डायरेक्ट बियरिंग बट वहाँ पे
ये
क्लोज बियरिंग हो रहा है। नहीं नहीं, राइट वाला सर, उसके राइट वाला। हाँ ये।
ओके,
हाँ, तो वहाँ पे सर हाई शेयर कंसंट्रेशन वाला प्रॉब्लम नहीं
यहाँ
आएगा
शेयर
सर?
का concentration आएगा ना, yes, yes,
तो फिर
आएगा ना.
उसका
See, so as I already told you, as a structural engineer, I will be happy to provide column like this because my beam will rest directly on the column,
हम्म,
and there will not be issue of the shear, more shear on this beam. इस बीम पे shear नहीं होगा, but there is a possibility कि architect will not be happy with this if it is not equal distances, let's say this x distance, x distance. अगर ये नहीं रहेगा तो फिर architect बोलेगा नहीं नहीं मुझे इधर ही चाहिए column. ऐसे हो सकता है. So now if there is a problem, architect is not agreeing and it is really a problem, functional aesthetic problem, genuine problem रहेगा तो हमें सुनना पड़ेगा. Then I will design this beam, let's say B6. So it will be more shear on B6 due to this load. Let's say B4. So B4 का shear इस पे जाएगा and then you need to design shear reinforcement for B6 because it is not directly resting on the column. होगा ना वैसे?
तो वहाँ पे reinforcement मॉडल करना मतलब ज़्यादा कॉम्प्लिकेटेड नहीं हो जाता होगा?
नहीं कुछ नहीं. It's not a big deal. ये वाला ना
हाँ.
इतना बड़ा नहीं है. मतलब technically it's possible, very easy. Shear reinforcement will not be much closer. Huh? Please try to understand. Whenever you design beams for different loadings and different projects of like this maybe, तो वहां आपको पता चलेगा. See this, if you ask me what will be the shear reinforcement here due to this point load, I know that it will be something T8 at 150 center to center, and I will have a depth of beam, let's say something 600 something. Okay. और इतना ही आएगा 8150, which is not a big number. So even though ये ऐसे डिसीजन लिया तो भी ये इतने में ही हो रहा है. So it's okay. I know that it is not a good choice, but sometimes we need to agree with such a solutions because architectural भी है ना importance. दोनों को कहा तो एक golden mean निकालना पड़ता है. ये possible ही नहीं, there is a big problem to this, then definitely we can ask the architect कि structurally possible नहीं. But I don't think so this is really case.
Okay, sir.
Yeah. Now there is one problem whenever we do the concept planning. So concept planning we are doing because we need to prepare the model. But before preparing any model in the software, you should know the overall concept planning, which is feasible, we can say feasible solution and feasible planning. So this is a feasible planning we are trying to develop through brainstorming and creativity and through our previous knowledge. तो इसके ऊपर ये चल रहा है हमारा. So there is a good load path and all these things are there. Now I ask you, generally we assume the sizes of beams. तो कैसे start करने का मतलब assume कैसे करने का size? It's very difficult to assume sizes. Now I am not modeling here because see classrooms are same like this here. So you will also provide column यहाँ डालेंगे ऐसे. Similar to this only, this will be like this. यहाँ एक column रहेगा, यहाँ एक रहेगा ऐसे. Then I will have a beam like this, then one more beam, secondary beam here, then two-way slab like this. So ये same ही रहेगा. So I am not drafting here because it is same. So need not to bother much here. Here we will discuss. I am going to plan here at this point. But before that, let's tell me if you want to assume the size of B1, what will you assume? Modeling करना है हमें, design करना है या. So you should know the approximate sizes.
So depth will be span upon 10.
Yeah, roughly 1/10. So first point is that general depth available for beams, whatever we take, we can take 375, 450, 500, 525, 600, 675, 750. Like this we take. Okay, 900. General depth, width we know 230 we start with, so there is no problem of width, but depth we can start with this. Now let's say B1 का कितना span लग रहा है आपको? 3 meter है, 3 meters या something. So if it is a 3 meter, 300 divided by L by 10. So it will be 3000 divided by 10. So 300. So you can think of
300.
375 ले सकते हैं यहाँ. Okay, एक minute. So let's say 375 here. Then ML beam, it is a mid landing beam. It is 4.3. So let's take 450. Then ये कितना है मेरा? 7.7 roughly. Correct. तो 7.7 का कितना आएगा? Roughly 750. Right? L by 10. It is not an
Yes.
exact rule, it's a thumb rule. Please keep in mind. So ये भी मेरा 750 आएगा. ये beam depth, ये जो beam रहेगा whatever. And again same here 750. Now tell me, ये WC के यहाँ ये जो beam है ये कितना लेंगे? So it is something, ये 6.7 divided by 2 है ना, half span हुआ आपका. So roughly 375. Right? Then for staircase, this one, it is 6.1. So let's say 600. This one is 600. So how we start with the planning, because deciding the sizes is a really important thing. अभी ये कितना आएगा? This one also you can think of 750, 750, this one 750 here. And this is 6 meters, so you can think comfortably 600 here. Yeah, 600, yeah, 600. Now there is one important point I would like to share with you. So ये तो समझ में आया thumb rule roughly. Okay. Now there is one possibility that let's say मैं instead of 600 यहाँ 750 लेता हूँ. Let's say this is your 600, this is your 750, and let's it's the span is little more here, so I'm taking 50. So do you think it is a really good choice keeping different beam depth here? So one is the thumb rule, what we discussed, and second is the aesthetic part. Many times what happens, if there is a elevational issue, then you need to keep the beam depth same. अभी यहाँ बताओ, यहाँ you know that whenever you see from this side, whenever you enter the school, you will see these beams. And if you have the beams depth different, then it will not look good. समझो ये सामने से देखोगे आप तो समझो ऐसे कॉलम से ये एक है, ये so let's say this is my 600 and this is my 750 and this. If you look from the entrance, ये अच्छा नहीं दिख रहा bottom, correct? Aesthetically लग रहा है अच्छा, आपको नहीं लग रहा ना? Because this bottom is in not in one line. So and let's say this span is more. If you feel that 750 I require as a structurally I cannot manage without 750. So there is a choice that you can increase these sizes. Okay. तो ऐसे कर सकते हैं हम, all 750 करो. अगर आपको structurally problem है तो then make it 750 all. And then if you do this, then it will look good, because the bottom line of the beam is same in one line, and it will give a good, we can say, feeling, aesthetic feeling, we can say. So you should also think of the aesthetic part and elevation part. So whenever you decide any beam size, see the aesthetic part and elevations also. Elevations, many times elevations are important. And definitely structural, it is always there, structural aspect. So structural means I generally recommend give more focus to the serviceability first, means to start with, and then strength and durability and all this, it comes, there is no problem. But please, you should see here also serviceability. Now this will be good choice then in my case. 750, 750. Then this will be 600 something. अभी यहाँ भी एक choice है ये वाला. So let's say this is your B1 is 600, this B2 is also 600. And what size you will take for B4? The span is 3.82. As far as thumb rule is concerned, it will be something 375, right? 375 आ जाएगा ना, as far as thumb rule is concerned. But many times I even try to keep the beam sizes same in continuation. Mostly, I'm not saying always. There is no exact rule to this. So I will be happy if I can provide 600 depth over here, if my column orientation is like this. Okay. Now, can you please answer me, what will be the benefit of keeping this beam as a 600? 2 minute के लिए aesthetic छोड़ दो. Let's discuss on this first. So ये मुझे ये करना है. If I make it 600, what will happen? And if I make it 375, what will happen? So there are two cases. One is 600 throughout, and one is 600 and 375.
So distribution of moment will be uniform.
Yeah. So So in one case, I told you that I am keeping so in one case, I say that the beam depth should be same, like this. In other case, I am saying that this beam depth, as the span is more, I will keep this beam depth more, and as this span is less, I will keep this beam depth less, because I don't require, because the span is very less. So there are two choices for anybody. There is no problem. As this span is 3.8, I will take 375, and this span is 6 meters, I will take 600. तो अभी ये मेरा 600 है, this is 375 deep, and here both are 600. So in both the cases, all of you know that there is a load over here. Load तो है ही, slab beam, wall वगैरह का. We have a bending moment diagram. Now let's say when this is the case, what is happening here? So due to the span, the bigger span, the moment will be high here in this case. Let's say something like this. And as this is smaller span, the moment will be less. But as the depth, we are keeping the depth same. So what will happen? This will have a uniform distribution. Let's say something like this. Okay. And you will see that the difference between the two moments. So the moment of this beam, let's say B1, I'm just giving this B1, B2. So this B1 will have moment here, something moment to the left side, and then B2 will have moment on the top. Let's say this is 100 and let's say this one is 90, for example. So what is the difference between the two? 10. See, you can observe this in models, but I'm just giving examples. So this will have this 190. So the difference between the two is 10, and all of you know that whatever unbalanced moment is there within the two beams, it will go into the column. So column में ऐसे moment आने वाला है ना. So this moment will be 10. Getting? This is my unbalanced moment. See, I assume that all of you understand the bending moments. So 100 minus 19, 10. So this is the case. Now here you will see as the beam depth is more over here, definitely the moment is more here. But this beam depth is very less, its capacity is less, so it will also have a less attraction of the moment. So ये कम attract करेगा moment. Okay. That means, let's say if it is 100, ये ऐसे कुछ तो 70 or 60 भी हो सकता है. Say for example, let's say this is a 60. So there is an unbalanced of 40 kilonewton meter. And that 40 kilonewton meter will go into the column. Now in both the cases, you will see that whenever you take this decision, the moment in the column is less, and whenever you take this decision, moment in the column is more. And this, you know that your moment direction, ये 230 है मेरा column का direction. And whenever you design any column and your this is your minor moment, we can say. So let's say this is your column. ऐसे कुछ तो column है आपका. And your moment is about this axis. ये मेरा minor axis है. So my moment is 40. And here it is only 10. Minor axis moment. My, let's say. Yeah, my. So all of you who have already learned the Excel programs and manual calculation, you will understand this. Matlab, and all of you know that whenever there is a maximum value of moment on the minor axis, the column design will be very heavy. Heavy हो जाएगा मतलब steel ज़्यादा आएगा उसमें या size भी ज़्यादा लगेगा maybe. So that is the decision. So whenever you take such a decision, then these are the implications. Now through these sessions, I'm just giving you the guideline how to think over this. So see, we are thinking architecturally, we are thinking structurally, we are thinking serviceability point of view, we are thinking analysis point of view, bending moments, and so on. So there are a lot of things which we are thinking in that direction. So, and as I told you, we are developing a thought process. So this is not the end, rather I would say this is the beginning of your thought process. You may learn new things here. So essay. So I would be happy to provide 600 here because this column will have then lesser. मतलब जो अब मैंने अभी बताया था वो ये है. ये मेरा समझो कितना आएगा? ये 10 ही आएगा इस केस में. And इस केस में ये 40 आएगा. Example मतलब. But no, actually, if it is a weaker axis, I'm talking. So let's say if it is a weaker axis, because whenever we compare, please keep the same condition. तो फिर वो गलत हो जाएगा. If both columns are horizontal, then and then I am talking. Otherwise, you cannot compare the things with different parameters. If this is the case, वो हो जाएगा. और deeper axis रहेगा तो फिर वो और कुछ अलग होने वाला है. So this is one criteria of deciding the depth of beams. Okay, so not always L by 10, but sometimes these are the cases की जो moment आपको लग रहा है कि ज़्यादा column attract नहीं करना चाहिए. So you can keep the more depth for the even smaller spans. And second was the aesthetic part, architectural. If architect is interested in keeping the same size, even though there is no load, even the span is not more, still you need to provide more depth. So there are a lot of parameters by which we think and decide the sizes. And slab का thickness तो आपको पता चला है. You can use Excel programs and just put the loads and get the thicknesses. So ये मेरा, I would be happy to provide 200 in this case. And here I would be happy to provide 140 if this is the case, 140. Okay. Then staircase का thickness कैसे decide करेंगे? You need to also design the staircase by using these Excel programs. One way slab का लेना पड़ेगा आपको, simply supported one way slab. Okay. And then you can put that finishing load and steps का load सब डाल के, then you need to think. Thickness of slabs generally, staircase slab are more, 200, 250 something. See, if you don't provide this beam, what will happen to the staircase? अगर ये beam नहीं रहेगा तो the span of the staircase will be how much? इतना होगा ना? यहाँ से यहाँ तक होगा ना? Yes.
Yes, sir.
And if you design this staircase and your thickness is coming out to be 300 mm, let's say, and which you feel that it is very thick. So how can I reduce this? So if you want to reduce thickness of the staircase slab, then provide one intermediate beam, and then this one, and then you can reduce this span, and you can control the thickness. So if you want to control the thickness of slab, control the span of the slab. Many times we don't have any control over the loads. अगर ये क्लासरूम है तो 3 kilonewton ही लोड रहेगा उसको तो कंट्रोल नहीं कर सकते, but we can control the thickness of slab and ultimately then dead load of the slab. So once you have the lesser thickness of slab, then you can have lesser dead weight of the slab. Okay, in that case. So that, and even for beam case also. So if you want to control the thickness of beam or depth of beam, how can you control depth of beam? How can you?
So by providing it doubly reinforced beam.
Doubly reinforced is should be the second criteria. First is the providing columns. Simple criteria, provide additional columns. So first case is, let's say I don't want this 750. Okay, for example, so I can think of putting one column there. So there is one choice, having column here like this, and then I can reduce the depth of beam. This is one criteria. If it is not possible to put this column here, then as you said, we can try for doubly reinforced beams. And here, let me tell you, if I want to reduce the depth of this beam B2 का, तो कैसे reduce करेंगे? As I already told you, you can control the bending moment values by giving the continuity to the beams. So B2 पहले continuous नहीं था, single span था. Once I provide this beam, then it is a continuous beam, and once you give continuity to the beams, the bending moment will reduce and they will distribute uniformly among each other, and then you can control the depth of beam. So because see, depth of beam is decided by strength criteria, that is bending moments, and second is the serviceability criteria, deflections. So deflection or moment, once you control the deflections and moments, even deflection will reduce by adding the continuous beam, isn't it? ऐसे होगा ना? किसका ज्यादा deflection रहेगा? Without B3 या with B3?
Without B3, sir.
Without B3 deflection will be more because उसको share करने के लिए कोई नहीं है, and with B3 the deflection will be less. So there are two benefits. Deflections are less, that means serviceability criteria is very good, and moments are less, that means the steel will be required less, depth will be required less. So it is always better to have a continuity to the beams. So that is the, we can say, underline point. Try to have a continuity to the beams so that deflection bending moment will be reduced. And third point is the redundancy will increase. Redundancy मतलब क्या पता है क्या? Redundancy टेक्निकल टर्म था, हमारे कॉलेज में यूज किया है ना हमने. What is the meaning of this redundancy, or we can say indeterminacy? क्या मीनिंग है? More degrees of freedom actually होने चाहिए. More degrees of freedom मतलब, see, at any joint there has to be 6 degrees of freedom. वो तो पता है आपको, 6 degrees of freedom are there at any joint. 3 forces and 3 moments, right? So we call it as a rigid joint or fixed joint. So whenever we have more joints and more degrees of freedom like this, 6 degrees of freedom at each joint, that means I would say redundancy means to have more joints, more members. And once you have more joint, more members, if there is a case of overloading or any problem to the structure, if it wants to fail, it will not fail it easily. अगर उसको लगा भी मुझे फेल होना है तो भी इतने मेंबर्स है इसमें, इतने जॉइंट्स है, सो वो स्ट्रक्चर को इतना कॉम्प्लेक्स किया है हमने, रिडंडेंट किया है, सो दैट if one or two beam fails, it will not fail the whole structure because the other people will share it. And other people means other joints, other members, they are sharing all the other this, ये दोनों का जो लोड है वो ट्रांसफर हो जाएगा अलग अलग जगह, and then that will take care, and overall the redundancy will take care of the collapse, matlab it will prevent the collapse, we can say. So that is the case. So having continuous beam is also a good choice generally in structures. अभी इतने बीम्स इतने कॉलम्स रहेंगे तो स्ट्रक्चर को फेल होना होगा तो भी इतना आसान नहीं है. बट इफ आई से कि मुझे ये कॉलम नहीं चाहिए, वो कॉलम नहीं, थोड़े ही कॉलम चाहिए समझो, instead of 10 columns I require 5 columns only, then that structure will have a serviceability issue, that will have a possibility of failure in earthquake or in other loading, extreme loading conditions. लेकिन ये स्ट्रक्चर नहीं होगा. So see, I can design any structure. Let's say अभी ये मुझे करना है ना, तो यहाँ मैं ऐसे भी कर सकता हूँ. Why to provide so much columns? यहाँ एक कॉलम डाल दो, ऐसे एक कॉलम डाल दो यहाँ, एक मिनट, यहाँ एक डाल दो, यहाँ एक डाल दो. क्यों डिजाइन करना है ज्यादा इतना? यहाँ एक डाल दो, खत्म. और ये एक बीम कर दो यहाँ, ये एक बीम. लेट्स डिजाइन थिक स्लैब, लेट्स डिजाइन थिक बीम्स. जाना दो, ज्यादा कुछ सोचने का नहीं है. सो विल इट हैव अ रियली गुड स्ट्रक्चर? छोड़ दो ये, बाकी खत्म. यहाँ कॉलम, ये 4 कॉलम्स, एंड देन डिजाइन इज ओवर. Why to provide such as 8 columns डालने यहाँ? Because I know that once you have less number of columns, less number of beams, then problem है उसको. Okay, so I hope you got the overall thought process behind this. Now here also, I think you are not aware of this, but for this lab it will require library. So here there are classrooms 6 and 7. So it is framing will be like this only. Either you get use this framing or this framing, whatever you feel. So you know the thought process. So there is no any stamping to the decision. You take any decision, plus be ready with the implications. Now these classrooms are same, these are same, so I will not go in detail with that. And the passage is also same. So it will replicate, I would say. It will be same like this here and here. But here you will find something different, which is a library. अभी मुझे लाइब्रेरी का प्लानिंग बताओ. अभी यहाँ से वो एंट्रेंस है, there is an entrance to from this and there is a library room and the dimensions of the library are 11.8 meters, means roughly 12 meters by 9 meters. अभी बताओ कहाँ कॉलम डालना है, कहाँ स्लैब करना है, कहाँ बीम डालना है. प्लीज, नाउ इट इज योर कॉल.
सर 11 मीटर का जो स्पैन है उसमें एक तो चारों कॉर्नर्स में कॉलम होंगे, फिर बीच में भी कॉलम्स हम देंगे इक्वल डिस्टेंस पे.
So you are saying that I will provide. So charo corner, say whenever you start with the corners first. Okay.
यस सर.
Start with the corners. It is always a good start. Then 11.8 meter मतलब इसको आधा करेंगे span को. Why not to provide like this? Yes. Then is it 9 meter is okay for you or उधर भी
सर
डालेंगे?
टू कॉलम्स वी कैन आल्सो प्रोवाइड टू कॉलम्स. जैसे हमने एक 11 मीटर का आधा किया है, एक
हाँ
कॉलम
वैसे
दिया
वहां
तो
भी कर
ये
सकते हैं.
दो कॉलम भी दे सकते हैं.
यहाँ एक डाल दो. ओके. अभी क्या करेंगे इसको?
सर यहाँ पे बीम्स दे देंगे.
So the beam span will be 9 meters. So either one choice is, can you provide here like this? See, as a first instance, structural का आदमी तो बहुत ही आसान करेगा पहले. And in library, many times this may not be a architect may not be happy with the situation in libraries, especially. हो सकता है, and yes or no, both case. Many times they have a sitting arrangement over here for study और करते हैं बहुत बार. So let's say this, if this is the case, then the problem is very easy. Then provide beams here, here. So ये मेरे beams ऐसे आने वाले हैं. This will be beam, this will be beam, this will be beam, this will be beam, and all round all beams. And my problem is very easy. बहुत ही आसान हो गई. ये 4.5 meter का आएगा span of the slab, and this one is 6 meters something, and I will have a 2-way slab, and it's very easy problem now for structural point of view. So this is one of the case by which you can do this by keeping this one column inside the room. Now let's say architects is saying that I don't want this column. So let's say you have given this solution to him and he's disagreeing with this. He's saying, no, I don't want this column. Now let's go back. भी प्रॉब्लम है करने का सॉल्व.
सर इन दैट केस कैन वी प्रोवाइड फ्लैट स्लैब्स या फिर पोस्ट टेंशनिंग कर दें स्लैब में तो
Yeah, post tensioning for bigger slab is okay, fine. But see, for the time being, I am saying that don't think of the PT, because in that case our rule goes off. See, are you getting? So first always
Yes, sir.
try to give the solution with respect to RCC, because क्या होता है problem में बताता हूँ. So why I am avoiding that? The reason is, say let's say ऐसे आपका ये पूरा building में तो हमने ये beam डाल दिया यहाँ. We have provided the beam, slabs and all columns and everything. Only for these slabs, is it really feasible to get the PT post tensioning system over here? Shall we put the different order and then coordinate with the post tension agency and then give the solutions? मतलब
नो
ये
सर, फिर एक स्लैब के लिए वो
एक
सर
slab
कॉस्ट
के लिए
भी फिर
अच्छा नहीं
ज्यादा
है ना.
होगा.
इसलिए वो क्या होता है बहुत बार, you need to take a decision. If your major part of the slabs are like this, then definitely PT would be a good choice, provided you don't have any RCC solution then and then. Otherwise, first think from the RCC point of view, because most of the building area is governed by the RCC design. Mostly, it is very rare case like IT park and commercial buildings where there is a possibility that we need to go for whole slab as a PT slab. But such kind of building, school or college or residential, better to provide RCC. Now अभी RCC करना है, चलो फिर कैसे करेंगे बताओ.
सर देन कॉलम जैसे ये जो दो कॉलम है बीच में 11.8 मीटर स्पैन में, उनको हेवी कॉलम देके और सर इन दोनों के बीच में एक डीप बीम दे सकते हैं, हेवी रीइंफोर्समेंट की भी दे सकते हैं.
So there will be, we can say we need to provide deep beam. Yes, this beam will have more, we can say, span, right? So whenever you have bigger span of the beams, you can increase the width. Please keep in mind. So as I already told you that you can start with 230 mm width of the beam. Whenever I say, it is not a final rule. In general, if the spans are roughly 4 to 5 meters or 6 meters, 230 is fine. But if the span is more than 7 meter, 8 meter, 9 meter, then you can go with the width of the beams as either 300 mm, 350 mm, or even 400 mm. You can take width like this also, and even 450 mm. This width. Because what will happen when the span is more, the steel will be required more, depth will be required more, and as steel requirement is more, you need 4 leg stirrups, 6 leg stirrups like that. And for providing that, you should have more width to the beam, so that there will not be any congestion of the steel. So when bigger span are there, increase the width. Don't only stick to this width only. It will have a problem, congestion. And whenever I say increase the width, first design it, then you will automatically understand कि क्या हो रहा है. समझो ये 9 मीटर का बीम मैं डिजाइन कर रहा हूँ एक्सेल में, समझो आपको ऑलरेडी मिलेगा सब उसमें स्टील. देन यू कैन थिंक कि इतना स्टील मैं डाल सकता हूँ क्या इतने विड्थ में, अगर नहीं तो फिर इंक्रीज. So it is not necessary that whatever I am telling you as a thumb rule and guideline, you should follow it. You should first check it in the Excel, check the design and verify it whether you can do the detailing properly. And if you can do the detailing properly, agree with it. And if not, then increase. So see, these are only guidelines and guidelines to develop thought process. This is not final rule. वो पहले ध्यान में रखो. The conceptual planning is not a final rule. I see we have taken such a decisions last week में, और आप भी जो हमने काम किया, कितने decisions बदल रहे थे हम. We were changing decisions like anything. कभी ये डाल रहे, then sometimes I'm removing, sometimes I'm rotating this column, sometimes this, that, sometimes adding this beam, sometimes I say that okay, what I can do this. So it's your choice. Okay, so let's come back to this. Now we can provide this 9 meter beam depth. कितना लेना पड़ेगा हमें? What is your choice? L by 10 रहेगा तो it will be 900 something, isn't it?
Yes, sir.
So 900 mm, and you should ask to the architect whether this depth is okay. Whenever you ask, you are saying that my depth requirement is this structurally. So he may say that my floor to floor height is very less and 900 mm will have a problem to me. ये बहुत ही नीचे आएगा. समझो let's say अभी ये library room generally school floor to floor height is more. Let's say I'm assuming for the time being ऐसे हो सकता है. ये समझो school building 3 meter का ही है, समझो floor to floor height is 3 meter only. And if you have this floor to floor height as this is 0 and this is 3 meters, say, and if it comes out to be 900 mm depth, 0.9 meter का depth रहेगा, तो ये कितना रहेगा इधर?
0.1 sir.
0.1. All of you know that 2.1 is the door height. अगर door के lintel level तक ये beam आया है, समझो बीच में, in between the room, so will it be really good choice? आपका हाथ भी जा सकते हैं वहाँ, right? So that
Yes,
means
sir.
this depth will not be acceptable. So it will have a real issue to the architect. Architect, you can talk to architect, either allow me one column in between, or I need this depth only. So what can you do? So many times what happens, actually this is not the case in school buildings. We generally have a more floor to floor height because the spans are more. It is generally 3.6. Okay, 12 feet roughly. It may be 12 feet. So 3.6 अगर रहेगा तो कितना होगा फिर फ्लोर टू फ्लोर हाइट? ये कितना रहेगा then? 3.6 minus 0.9, it will be 2.7,
sir.
which is very comfortable. Not it's 9 feet roughly. So this can be acceptable. Still, architect will not be happy with this. He is always will resist to you. Please reduce this size. Please reduce this size. ये वो होता है. Debate and disputes will always be there. Please try to stick to your problem, say solution, as long as you feel that your solution is good, safe, serviceable, and all. Please don't change your decision immediately, because whenever you change the decision, there is a problem to the safety. Please keep in mind. So if you feel that this depth is a must for me, then please stick to it. Then let the architect find the solution first, whether he can do any change or not. अभी इस केस में I have one more solution अभी in our case, which we have used it previously for different spans. So as you said that there is one choice is post tension slab. So I will remove this and I will try to provide a post tension slab. So that is one choice, but for a smaller project, as I told you, it's not good choice. So is there any choice? Anybody knows? कोई अलग choice है क्या आपके पास?
Sir, flat slabs are different from post tension slab, or they are same things?
See, yeah, flat slab. You can do RCC flat slabs, or you can do post tension flat slabs. So flat slab is also possible here, we can say.
Okay.
But it
Okay.
depends what depth you get for the, because whenever you provide flat slab, you need to provide like this also. समझो,
Yes, sir. Column के ऊपर एक
एक minute.
column capital.
You need to provide the drops like this, okay, in the flat slab,
Yes,
because
sir.
there is a more shear at the column point. So generally ऐसे करना पड़ता है. Yes.
Sir, but
So
these
this is
drops can
also
also help in the aesthetics of this library room.
it can, yes, architect will definitely use this thing, because see, they always, whenever you insist on your part, then they will also find their solutions. So there is always a possibility
Yes, sir.
that structural elements can be used from aesthetic point of view. To see, let's say, if this will be the ceiling view, you can say. So I think it looks okay or good, isn't it? कुछ अच्छा है मतलब. There is a less symmetry है कुछ तो. So there is a, I can say, geometrical rectangular shapes, and it may look good. I think it looks good, not bad actually. At least
Yes,
it is
sir.
not bad. So yeah, this is also one of the case, but in this case also the slab thickness will be more, and as I said, when the thickness of slab is more, serviceability issue is a problem. You can design, अभी ये डिजाइन करके देखेंगे, चलो 9.1 मीटर by 11.8, let's say हमारे पास एक्सेल है. See, there is a really great benefit of this Excel programs कि हमें हाथ से कुछ ज्यादा करना नहीं है, डायरेक्टली जस्ट पुट द नंबर्स एंड यू गेट विद इन मिनट्स. अभी ये कितना मेरा, लेट्स से नाउ इट इज अ ऑलमोस्ट सिंपली सपोर्टेड केस. सिंपली सपोर्टेड ही लेंगे चलो, बट आई नो दैट इट विल रिक्वायर मोर थिकनेस. चलो, so let's say it's a 9 case. Nine 9.15, 11.8. ये थिकनेस तो ज्यादा लगने वाला है, लेट्स से 250 करता हूँ मैं पहले. Now, as we have seen, if the library का ये top slab है, मतलब see if the library is
kilonewton.
at first floor, ये 6 kilonewton, which is very big number, but okay, लगेगा तो लगेगा. Quite huge load, You will see that आपका thickness तो कभी भी बैठने नहीं वाला. आपका 12 का mm का बार भी डालता हूँ. Let's see. Your depth requirement itself is more, so just go ahead. 250 नहीं ये possible. Let's go with 350. For slab, this thickness is quite huge. Steel also required more. MM at 85 लग रहा है इसको. Okay. Still it is saying reverse thickness or AST. So it is really, load is very heavy. You can go with 16 mm bars also in such cases, which you will not see.
Sir, can we also increase the
What?
FCK?
Yes,
And
you have a FCK, but that will not give you much difference. You can increase, yes. अभी बड़े स्लैब रहेंगे तो 30-25 तो लेना ही चाहिए कम से कम. But may not, if it is at the boundary, it will help. Otherwise, generally, changing the thickness is a really good choice always. It helps you for serviceability and even for steel percentage and strength and all. तो मुझे लग रहा है ये 375 में बैठे. 400 thickness of slab is not a joke. Okay, it will definitely अभी पास हो रही है, but this is serviceability issue may be there. इतने thickness के लिए इतना बड़ा span है. So okay, but let's see, not bad. कर सकते हैं यहाँ. All of you know that there is a middle strip and all the strips will be there here. So the thickness requirement will be more in this zone only, but not here. So okay, but you should know what are the options available and what can you do here. Post tension flat slabs or RCC flat slabs like this. And there is one more case. So all of you know that grid slabs, पता है क्या आपको कभी?
Yes sir.
Grid slabs.
जिसमें बीम, yes sir, बीम्स के ग्रिड्स बने होते हैं. वॉफल स्लैब्स भी बोलते हैं सर उनको शायद.
हाँ, वॉफल बोल सकते हैं, बट ग्रिड मैं फ्लैट बोल रहा हूँ. वॉफल भी बोल सकते हैं, राइट? नॉट बैड. दोनों भी यूज करते हैं वर्ड्स. So we can provide, and generally the beam width is 200-230 ले सकते हैं, and ये हमारा 6 मीटर है ना, समझो तो एक 1500 1.5 मीटर स्पेसिंग. So they are always closer, ऐसे रहते हैं. So this will be your one-way side grid. So as our slab is two-way slab, all of you know this 9 meter by 12 meters. So it will be two-way slab. So I will also provide the vertical grid like this. So it is having a little different philosophy. I will just give you. Getting? So in this case, also beam depth maybe around 450 or 500, it will be sufficient. 450 maybe something. And then there will be smaller slabs between this. So here every slab is a smaller slab. So the concept is different here. Please try to understand. So this is local behavior, but actually in totality this grid slab is nothing but a two-way slab. So try to understand, this is a two-way slab, and all of you know that two-way slab is having a triangular distribution like this. ऐसे ही रहेगा ना ये इसका distribution. And trapezoidal distribution, right? So the load will transfer like this only. We will have a beam at the boundary, all boundary pe beam bhi hai, all boundary, and the load distribution. So I can say that this 9 meter by 12 meter slab, I have done the stiffening at intermediate levels. Okay, so it is a two-way slab, but we are putting the steel in the grids within the beams. So these small beams are acting as a part of the slab, we can say. So try to understand. You can model this in ETABS or STAD Pro, whatever you want, and you can see the behavior. It is nothing but a two-way slab values. So it will be something like this only. Now here what is happening, you are getting steel kitna raha hai isme 16 at 150 spacing. Okay, so instead of, and this is uniformly distributed. If I want to put the steel into a slab which is flat, let's say for example flat slab में डालना होगा तो कैसे करूंगा मैं? This is my 9 meter by 12 meter slab. And I have calculated the steel and it comes out to be uniform like this, which is 16 at 150 center to center. This is my 9 meter and this is my 12 meter. And there will be vertical distribution steel also because it is a two-way slab. And let's say this is 16 at 200, whatever design is coming here. So this is the two-way slab, flat two-way slab design. But in our case, it is grid slab. So in that case, what happens? Whatever steel is here, we are concentrating that steel within the strips. What I'm doing, steel percentage is same, but I'm just putting concentrated steel. So in every beam, I'm putting the steel. यहाँ जो beam है ना मेरे grid. So I am putting that steel within the each grid, and these beams are acting as a, we can say, one-way direction of the slab, and this will have two other direction of the slab. So this is also one of the case. And this way we can say we can do the, we can say, overall planning of the structure. Once you put the columns, beams, slabs, everything you do, and then once you do that, then you can go to the model of ETABS and do the modeling of ETAB, then design it, check it. If the design is not satisfied, if the depth are not sufficient, increase the depth, increase the steel, whatever you want, and then go. And you should see, first we need to submit this drawing to the architect, then you should agree with all the parameters, discuss among yourself, and then finalize the solution. And once you finalize the solution, go to the model, ETAB model, then do the design and do the drawing. So this was the overall aim of this session. I will just show you the plan also, AutoCAD plan, which we have prepared. Okay, so abhi yahan, this is only just general planning. Here we have not yet taken any beam here. There was maybe problem with the architect. So it depends what issues you may come across with. And here we have provided the grid slab. Yeah, okay. And once you are ready with the, now here you can see, आपको एक मिनट दिखाता हूँ. Now here you see the columns offsets are outside. Huh? Can you see this?
Yes, sir.
What may be the reason? अब हमने तो अंदर लिया था, offset आते बाहर जाते. क्या लग रहा है आपको? Why these offsets are outside? Do we really take such kind of planning? लेते हैं क्या? Any views?
No, sir. In general, तो अंदर ही देखे हैं, sir.
हाँ, in general अंदर है. Yeah, but now then ये क्यों बाहर लग रहा है आपको? मतलब क्या रहेगा? What may be the thought behind this? who has taken this decision? आपको क्या लग रहा है? Who is the decision maker in this? Because in our planning as a consultant, we have not taken such a decisions कि taking column outside. Actually, this is the
Sir,
decision. हाँ, बोलिए.
is there any architectural
It's
or
architecture paper.
elevational?
Yes, yes. See, they want all these offsets. If you look from outside elevation, then you will see the fins. Vertical, you will see the lines, vertical lines. And that will give a good elevation, say from architectural point of view. You might have seen such kind of buildings where the columns are offsetted outside. And that offsets gives the elevational or aesthetic part. You might have seen this.
Yes, sir.
तो
Yes,
यहाँ
sir.
ये
Yes,
देखो,
sir.
ये all around you will see all around the columns are outside. So you will see the vertical fins, and it really gives. You can observe the college buildings, school buildings. Some of the college and school buildings are like this. Now, I request all of you who are freshers, who are students, or who are experienced people, whatever means, please observe different structures. As a civil engineer, we are lucky enough to visit any structure, any building. It may be commercial building, school building, college building, residential building. Please observe the structure, observe the beam locations, observe the column orientations, observe any elevational part like this, and please understand what may be the thought behind that concept planning, so that you will also get a good idea. Then even observe the spans of the beams, then check the depth of the beams. You can have one measuring tape with you. If you feel that if you want to measure that dimension, then you can measure it also. And then that will give a real idea. Let's say this consultant has given this depth for this span. And you may think why this architect has given these columns outside, or you may even see कि entrance पे जाने के बाद beam कैसे दिख रहे. So I'm just giving from this school building point of view, but you can visit any building, RCC building, and please think over the sizes, think over the column locations, think over the column orientations. So whatever you can observe, please observe that and think over it. That will give you a more knowledge, I would say. कि ऐसे कुछ बात नहीं कि हमें सिर्फ ट्रेनिंग में सीखने को मिलता है, ऐसे कुछ नहीं कि बुक में ही सीखने को मिलता है. No, you can learn lot of things through observations and thinking over the observation. So these are the things, the way we do the planning.
सर एक क्वेश्चन था. ये जब ग्रिड स्लैब को हम एग्जीक्यूट करते हैं साइट पे, तो हाउ दैट प्रोसेस इज कैरिड आउट? मतलब आई हैव नेवर सीन.
नहीं, शटरिंग कट करना पड़ता है इसको. So we need to cut the shuttering. ये ना, if you want to do it normal shuttering with ply, then there is a box here. You need to provide prepare a box here like this. अभी मैं दिखाता हूँ.
Sir, in some videos I have seen that there are precasted box of different size, or we can जो शटरिंग के फॉर्म में आते हैं.
हाँ, so there is a box here. Develop this. अभी ये साइज का बॉक्स बनाऊंगा मैं. एक मिनट. So box कैसे रहेगा मेरा? All round four sided will be the side plate or side ply, and there will be bottom plate of the slab. ऐसे सभी जगह ये बॉक्स लगाएंगे हम, and then we can do that.
Okay, sir.
So generally we keep the uniform spacing of the grid beams for that purpose only, so that I can make it modular. तो ज्यादा मुझे ये नहीं repetition हो सकता है.
Okay, sir.
So and that's why ये जो same है यहाँ ही किया है. Actually this is not a library building, but still the architect and structural consultant has came to this final solution. Why not to keep this together, so that they can have a, we can say, maybe symmetry, and then they can use this shuttering material here also, so that cost will be effective and so on. So sometimes once you have a meeting with client architects, we find good solutions.
Okay, sir. Thank you. Thank you.
Contractor is generally not happy with grid slabs. If consultant gives grid slabs, he is really not happy. क्योंकि उसको लगता है कि ये सब कट करना पड़ता है ना, प्लान एंड वेस्टेज इज देयर and the cost goes high, then client is not happy with the high cost and many problems are there. So you need to ऐसे बनाते बॉक्स, यहाँ ये स्क्वायर, ये स्क्वायर, ये स्क्वायर, and then मतलब this will be your box and
बीम की डेप्थ के अकॉर्डिंगली ये ऑफसेट होता है ना सर, ये
हाँ
नीचे वाला।
राइट। अभी ये दिस इज योर बॉटम लेवल ऑफ द slab and this is side of the beam. So if I see the section you will see like this. अभी ये मेरा अगर ये ऐसे कुछ तो होगा section. So this is my slab depth D and ये जो है portion ये मेरा actually box है ये वाला, then this one, this box. So I will keep each and every box here side by side. अभी whenever I have this box, then the bottom is done separately. ये bottom रहेगा ना beam का. Have you all of you have
Yes, sir.
visited any construction site? तो ये पता चलेगा ये bottom.
Yes sir, yes sir.
So bottom is kept first and then these boxes are arranged and then the propping is done for everything. ऐसे करते हैं सब. And then putting the reinforcement. Okay.
ओके सर, मतलब बीम स्लैब अरेंजमेंट जैसा होता है ये नॉर्मल स्लैब ही है,
हाँ,
बस
normal
उसमें
slab.
शटरिंग हम वैसा लगा के
शटरिंग लगा के
उसको
करते हैं
वैसा बना।
हाँ, करे, बाकी कुछ नहीं अलग. द ओनली हाँ अभी इसमें वन वे स्लैब बीम कहाँ से कहाँ तक है, फ्रॉम हियर टू हियर द बीम इज द स्पैन. प्लीज ट्राई टू अंडरस्टैंड एंड दिस इज नॉट दैट वी टेक वन वे स्लैब हाफ लोड इधर हाफ लोड. दिस इज नॉट द फिलोसॉफी ऑफ हाफ लोड और टू वे लोड. दिस इज द ओवरऑल ग्लोबल बिहेवियर. So try to understand. I know
Okay,
that
sir.
understanding this kind of structure may be a little difficult because it requires a little more, we can say, perspective, different perspective rather. So it is not that, see, some people feel that this smaller beam is resting on these beams. It is not the case. The beam is from here to here. It is not small beams because he will say that ये vertical beam है, main beam और ये मेरा secondary beam है. It's not the case. कभी कभी हो सकता है confusion. Okay, so
Okay sir.
this is overall planning and please try to develop a thought in these directions and I would be happy if you can do such kind of plans. So I suggest all of you as a matter of practice, take any architectural plan of any kind of buildings, RCC, residential, commercial or school, college, industrial, whatever you want. RCC but I'm saying for the time being. Do this kind of planning. अलग अलग ऑप्शंस तैयार करो, मतलब एक ही बिल्डिंग के चार चार तीन तीन ऑप्शंस कर सकते हैं आप. एंड जस्ट थिंक ओवर ईच ऑप्शन की ऐसे किया तो वैसे होगा, वैसे किया तो वैसे होगा. सो यू विल गेट ओवरऑल थॉट प्रोसेस डेवलप होते जाएगा. You can ask also to us questions if you have any practical problems and practical projects. If you are doing on your own, then you can discuss among us so that the learning will be continuous. So I hope all of you like these sessions, whatever. So this was the conceptual part of the session. Maybe upcoming sometimes in next month, maybe, I don't know. We may come with some different workshops. Which will also give you some different knowledge, we can say. So learning is a continuous process and that's why we are coming up with such workshops and whatever knowledge sharing part. I think all of you are on our technical forum group also. So you will get,
Yes sir.
Yeah, you will get some knowledge sharing there also.
Yes sir, workshop was very knowledgeable sir. Thank you sir.
Thank you. Yeah, Mr. Rahul Awasthi was saying initially L by D ratio से yes sizing करेंगे, बताया था. अभी क्या है, अभी वो मैनुअल रफली नहीं ले करते हम, हमारे पास एक्सेल प्रोग्राम है. सो डायरेक्टली हमारा डिजाइन 2 मिनट में हो रहा है, तो इवन प्लानिंग में ही यूज करने का एक्सेल इंस्टेड ऑफ एज्यूमिंग L by D and that डायरेक्टली एग्जैक्टली होता है बहुत बार, but okay, L by D is a quite classical method. Okay, then shall we close today? Okay, so thank you all.
Thank you, sir.
Thank you, sir. Thank
Thank
you so
you.
much.
Thank
Thank
you.
you.
And
Thank you,
good
sir.
day to all of you.